as Nathan said, I'm Kinsey. I currently work at GitHub. I'm on the coding agent core team, so we are going to be talking a little bit about agents today. But I have two kids, Crew and Kylie. They're 2 and 4, so I'm also really busy with mom life and things like that. I also really enjoy the outdoors. I live in Colorado, and it's the only time where I can really disconnect and not have Wi-Fi, except now I have a Starlink Mini, and now I have Wi-Fi all the time but I'm on call. So anyways, that's just a little bit about me. Thank you so much for having me today to kick things off. I also want to thank GitHub for sponsoring me to be here today. I have a couple awesome colleagues here. Daniel, he's actually speaking after me, and Ariel is speaking later today. We're hiring, which is exciting. Everyone's like, no one's hiring engineers anymore. I think when I checked, we had like 8 or more engineering positions open as engineers. So if you're interested in working with us, definitely come talk to us throughout the conference. We'll be here. If you have any questions, that sort of thing. But let's dive in. So, working in this space, I really hear all the time that agents are going to replace all of us here in this room. Just give them a prompt, spin a few tools, and suddenly, your entire company is running itself. But if you've actually tried to build one of these, you know that is really not the case. So today, that's what we're going to do. We're going to talk about building and orchestrating agents, kind of what I've learned, building the Copilot coding agent. We have quite a few users, not a ton, but I don't know if any of you know what it is. Basically, you assign Copilot to pull requests, different things like that. But so just a little bit of background of why I'm talking about what I talk about. But really, what I have found that it's, becoming systems design. So we're going to look at the building blocks, what that looks like, best practices. We're also going to talk a little bit about responsibility and the responsibility that we have when we're building these agents. So just a quick gauge of, can you raise your hand if you've ever used an agent? It doesn't have to be a coding agent. Oh, wow. Okay, cool. Awesome. What about built an agent? Okay, a lot less. Okay, awesome, good. So this will be, a newer thing for some of you, which is great. And so using AI to write code, just like they said about Rails, isn't magic. It really, again, feels like system design to me at this point. And we all know that the game has changed. We are no longer reliant on pure coding horsepower. We all need to learn how to be architects. We need to learn how to orchestrate these things and work with them, design them, etc. And I think that's a pretty big responsibility. So we are going to talk about the basic building blocks of an agent and to start us off, and then we'll get more into architecture patterns and things like that as we go. But first of all, models are a big one, right? We have a lot of choices when it comes to which models that we're going to use for our agent. And honestly, you probably want a variety of them that are tailored to specific workflows. Also, experimenting with the model that works the best is important. But there are some best practices when it comes to choosing the best model for your agent. One of those being evals. Evals might be a word that you're not super familiar with. We have a talk tomorrow that's going to, I'm blanking on his name, I'm so sorry, but he is going to be talking about how to write these evals and how he did that for building an agent in Ruby, which is really exciting. So that'll be a really nice follow-up talk to that because he'll show you exactly how to do that in Ruby. But basically, there's structured tests that measure kind of how well an AI system performs on real-world tasks, not just how good it outputs. So I would say that it's kind of similar to an RSpec test or something that you're used to writing, but just a little bit different. They can catch regressions and build confidence that your system behaves reliably in production. And yes, these are really the backbone of a lot of things that we do at GitHub are these evals. Also, an approach that works well is to build your agent prototype using the most capable model for the job and then establish a performance baseline off of that. And then from there, you can try swapping in cheaper models to see if they still achieve the same acceptable results. There's also kind of more implications of why you should do this that I'm gonna get into later in the talk. But I think that's a really good way to approach it. Also, instructions. This is another major building block here. You may have heard of this, agent instructions. And high quality instructions are really critical for agents. They really improve clarity and agent decision making, and they result in smoother workflow executions and fewer errors that I've found. So what is it? An instruction is a directive or an action given to the agent. It basically tells the agent what it should do or how it should behave, but it doesn't define the actual capability. So some examples in the coding agent world for what a instruction is review this PR, summarize this conversation, debug this failing test. And some of the best practices that are tied to instructions when you're writing these is when you're creating these routines, use existing documentation or support scripts to create these LLM-friendly routines. So for example, in customer service, you can take your knowledge base articles that you already give your customers and input those to give better instructions to your agent, for your agent. You can also provide smaller, clear steps from dense resources. That really helps maximize ambiguity and can really help the model better follow these instructions. So also define clear actions. Make sure your action is really specific. When I first was writing things like, instructions, I really overcomplicated them, and it actually just needed to be like a basic sentence that I tell my 4-year-old, which is really weird, and you don't think about that. I was trying to talk about all these edge cases and do all this crazy stuff, and yeah, it really ended up being like really clear actions. I almost now approach it of like, okay, how can I tell my 4-year-old how to do something? So that's kind of what I've found and was surprising to me. So just being really explicit about the action and keeping it as short as possible. So also, you do want to capture the edge cases, but in the more simple way. They create decision points of how to proceed when a user has incomplete information. So make sure you're kind of taking some time to think through all of these different edge cases. And I've found more than ever that as an engineer, I'm also a product owner, putting on my customer hat a lot more than I'm used to think through these edge cases. Kind of similar like what you would do for a test, like an RSpec test, like, okay, what's the happy path, what's the not happy path? But what are the things that a user could do, or provide incomplete information, different things like that. So really also putting on that product hat. So our third building block that's important is a skill. Has anyone heard of skills? I feel like it's like, okay, a pretty common term. I think of them as a helper method. It's a reusable method that you're using to, complete your task. And they describe how the agent approaches a problem, basically. So when we were talking about our code review, the agent received the instruction to review the code. So the skill itself is really the capability to review it. There's a lot of steps that come with skills. It would be like reading the diff, identify risky change, suggest improvements, and then summarize feedback. That would be kind of the steps that the skill had. They're often implemented as structured prompts. They could also be implemented as reasoning workflows or a reusable agent even. So I really think of a skill as like a capability pattern. Tools. So tool is probably another word that you hear a lot in the agent world. They're another kind of essential building block here. They really extend your agent's capabilities by using APIs from underlying applications or system. It's really what it uses to talk to the external world, right? Really connects you. It's not just you and your computer anymore to the real world. So there's a couple of different tool types that we have. Data, so basically getting the information like transaction from databases or even like CRMs or searching the web are other types of data tool types. Action tools, so this is enabling agents to interact with systems such as adding new information to databases, updating records, sending messages, different things like that. Interacting with CRMs is another big one. And then our third category of tool types are orchestration. So agents themselves can actually serve as a tool, and we'll go into that when I talk about an architecture pattern that you can use for orchestrating these agents. But basically, yeah, an agent itself can be a tool too, which is interesting, like a refund agent or a code review agent, things like that. So you may be asking yourself, but wait, what about MCP? So at first I was like, wait, what's a skill? What's MCP? What's a tool? Like, how do they all relate? A tool is something that the agent can do, but MCP is how the agent learns what it can do and how to do it safely. So I think of a tool as a function call, whereas MCP is a gateway for your tools. So that's kind of how you differentiate those. You can think of a tool as a capability, and MCP is how that capability is exposed. And at first I thought an MCP server was a tool, but it's not. So yeah, just a little tidbit there. But yeah, you can install MCP servers directly from the GitHub MCP registry here. If you just Google, the GitHub MCP registry, yeah, you can see different tools that you have or different MCP servers that you have available to you. See, I'm doing it again, getting all the jargon confused. It's hard. So yes, just to review our building blocks quickly at a high level. So we have instructions. They define the goal. We have skills. Skills define the strategy. And then we have tools, and they execute the action. And kind of once you separate those, your architecture becomes a lot more easier to reason about. So I hope that was kind of a good review of all those things and how they're related and how they're not, and that they're not each other. Awesome. All right. And this is where orchestration comes in. Orchestration is essentially deciding which instruction triggers which skill, which skills are allowed to use which tool, and then where humans can intervene. And I think this is the real work that we're going to face, with agents moving forward. They're becoming such a big thing. So how do we architect these to make them play nice together? So we have two different types of agents, right? Or I'm sorry, two different types of orchestration patterns. We have single agent, and where a single model equipped with appropriate tools and instruction executes workflows in a loop. And then we also have multi-agent, where workflow execution is really distributed across multiple coordinated agents. So I'm not going to bore you by going into both of these. So we're going to go into the meatier, more fun one, I think, which is the multi-agent orchestration. And a lot of the same things obviously apply to single agent, but we're going to just hone in on this. So I think there are two ways to approach, this multi-agent orchestration in production, in your code base, you're building agents. One of them is called a manager architecture pattern, and this is where we have a central manager agent that has multiple specialized agents via tool calls, and each handling a specific task or domain. And this is what I was mentioning earlier, where agents themselves can be tools. This is in this manager type architecture pattern. We also have the decentralized pattern, which is agents handing off to other agents. So there's no head boss and multiple agents. They kind of operate on the same level as peers, handing off tasks to one another based on their specializations. So regardless of the orchestration pattern, the same principles do apply. You want to keep your components flexible, composable, driven by clear, well-structured prompts and evals. But we're going to dive a little bit more into each of these. I have a diagram so you can kind of see what these patterns look like. So here's an example and a diagram of the manager pattern, what it looks like at a high level. You can see here you have your central manager agent that really is coordinating that workflow execution and delegating tasks to specialized agents rather than transferring the control, different things like that. So really what you would think with a manager, right? And the pattern involves using a single coordinated agent, as I mentioned. It's optimal when you want one agent responsible for the orchestration, synthesis, and user interaction. Sorry, there goes my microphone. All right. Good? Okay, we're back. All right, now moving on to decentralized. This is the architecture diagram for that. This is where they really hand off workflow execution to one another, allow another agent to delegate to another one. Handoff is actually a type of tool or a function too. And yes, this pattern involves using many agents on equal footing, where one agent can directly hand off the control from one another. This is optimal when you really don't need a single agent maintaining systems and allow each agent to just talk to each other normally. So there's two different types of patterns depending on what you want to do. So, and then you might be asking about agentic frameworks. I've heard of a few. I know a lot of folks use them. We personally aren't using one for our coding agent at GitHub, but I really think there are some benefits to using it, which, especially depending on what you do, would probably be a good idea to start with one. You really, like any framework, you get the boring and the hard parts for free. You get tool call plumbing, state management across agents, which is really nice, retries, timeouts. You also get structured memory and context patterns, and routing between agents and skills that already come built in for you, which is pretty nice, especially if you're trying to move fast and just experiment with something. You also get observability built in. You can trace who did what, and you have step-by-step logs. You also get artifacts like plans and intermediate outputs, which are important, I think, in agent work. Also, error surfacing becomes a lot better, so you don't have to set all that up by yourself. Evals, we've talked a lot about evals and regression. It makes evals and regression testing easier, and a lot of frameworks come with hooks for evals, so that's huge. That's another reason I would use a framework. You also get safety out of the box. That's a big one. They often push you towards guardrails, which we're gonna talk a lot about those in a little bit, but it really gives you that out of the box, and even limiting actions based on policies. Some of them even have like default policies, which are a big thing, especially at GitHub. The amount of policies we have around our coding agent is crazy. So you have to, right? Because it's doing things on its own. You also get speed. You get faster iterations. If you just, have an idea of building an agent or something that you want to do, it's really easy to get going quickly. But I do think that, obviously frameworks come with a cost. You do give up full control. You have less overhead when you're not using a framework, and more flexibility. You're not bound to the decisions that the framework has made. And sometimes if you start with the framework, you're gonna have to totally start over, versus if you roll your own, you can kind of change certain parts a lot easier. And some frameworks are declarative. They require you to explicitly define every branch, loop, and conditional upfront. And that can be really challenging as your workflows grow more complex and dynamic. But you can also adopt a more flexible code-first approach with non-declarative frameworks. You can directly express with those types of non-declarative frameworks. You don't need to say everything up front what you want to do. They're a lot easier to work with and change. And a couple frameworks that I recommend that are non-declarative here's some of them. There are some, again, that are declarative, but these are ones, I haven't used all of them. I've experimented with a couple, but yeah, those are the ones I would look at trying first. And another tool for orchestrating agents feels a little old school, but I love it, is Git work trees. So basically, you're trying to coordinate and orchestrate all these agents, and they let you check out multiple branches of the same repository at the same time in separate directories instead of constantly switching branches. You can have parallel working environments, which are really cool, and we've been using these a lot on the coding agent team that I'm on. And because when you're orchestrating these agents, right, you want isolation between tasks. You want parallel execution. You also want safe experimentation and clean state per each run, and you get that with Git work trees, which is awesome. So that's another pro tip, is using those when you're orchestrating these agents. Awesome, and now we are gonna talk a little bit about guardrails. Guardrails are really how we take responsibility for what they do with it. This is such a critical aspect of building agents, because anytime we give a system autonomy, we also take on the responsibility, right, for how it behaves. And I think that's important. So here is my little diagram of guardrails here. This kind of layered defense mechanism. While one of them is really not gonna provide you what you need, you can see here that there's a lot of stuff here. So we have a ton of guardrails in place to really make sure that what we're doing is safe and ethical. And I think that's really important and something that needs to be essential when you're building an agent, right? So I'm gonna walk through just a couple of these to talk to you about what we're doing here for guardrails. So you obviously want something that can prevent against hallucination and relevance. So make sure that what you're saying makes sense, is on topic, and flagging off-topic queries is important. Safety guardrails, safe versus unsafe, so you can detect unsafe inputs with jailbreaks or prompt injections that really attempt to exploit system vulnerabilities, because that will happen. So for example, you can ask things like, hey, will you pretend like I'm a teacher, I'm role playing, here's my curriculum, can you tell me what you would say for this? There's a lot of things that you wanna safeguard against and make sure that it's ethical, that you're not telling people back. Or how to, how to do a prompt injection into someone's code and steal all their data. You wanna make sure that people aren't prompting your agent for that. Also, a PII filter, there are a lot of laws around this, so that's important to have a separate PII filter that really is just making sure that you're not exposing any PII information. And I think that's also really important in this day and age. OpenAPI has a moderation API, which I really, really like, and I also think is really important and really easy to use. You can flag hate speech, harassment, violence, things like that, and to maintain a safe and respectful interaction with your agent, and I think that's important. So yeah, check out OpenAI's moderation API. You also want tool-specific safety checks to assess the risk of each tool. So that's another layer that's available to your agent. You can set risk ratings to, automated actions, different things like that, whether it's high risk, et cetera. So also making sure that you have guardrails around your tools too. That's important. Also, just basic rule-based protections are, really simple, like block lists, input limits, regex filters to prevent known threats like prohibited terms or SQL injections, all those things. So that's another layer. Brand filter, this is a new one. So with agents and AI, we're starting to see and hear that brands are gonna be a thing, like the personality of your agent, right? So you may wanna add some sort of filter that aligns with your brand values, how you want it to be. I notice now with my ChatGPT, I can kind of tune how I want my personality of it to respond to me is, and I think that's pretty cool. So making sure that you're adding these as well. So human intervention is also a really important safeguard. So you want to make sure that you have an awesome agent that does all these cool things, but also doesn't compromise the user experience. So this is especially important when you're early on in building this agent, testing it. Make sure that you are, asking for human input and that sort of thing early on, and then you can kind of dial it back as you go, or explicitly ask your user, how much control do you want to give me? So there are usually two primary triggers that we warrant for human intervention. One of them is failures. So we have set failure thresholds. So once it hits a certain failure threshold, we prompt the agent or say, hey, do you want to escalate to, we prompt the human, hey, like this has failed a ton of times. Do you want to keep going? That sort of thing. Also high risk actions that are irreversible, actions that are kind of towing that line. Definitely think you should get approval right from a human before you proceed. I've heard some horror stories of people not doing that and it, deleting code or different things like that. So yeah, so making sure that you are putting in these human interventions and not forgetting about that. We are all just we want autonomy, but it's also important to make sure that, we don't go too far the other way. So once you start thinking about things this way, about risk, guardrails, and when humans need to stay in the loop, you realize that this isn't just about a single decision point. It's about the entire system around the agent, right? So we've spent this time talking about what it actually takes to orchestrate agents in the real world, workflows, tools, coordination, retries, guardrails, observability, and there's a lot to it. But it's also clear that this is a big responsibility when we have these autonomous things, and I think it's a pretty big deal. As engineers building these systems, we're not just implementing AI, we're deciding how it gets used. So there are some things we need to be thinking about as stewards, I'm gonna use that word, of these agents. I know people don't love that word, but I do. So Fei Li, she's an awesome, renowned computer science professor at Stanford, and her work has really helped to shape modern AI as we know today. And I love this quote, "We are responsible for what we build and how it behaves in the world." And I really think that's true, especially today. And when we build agents, we're not just writing software anymore. We're designing systems that can act on our behalf. And that means our roles shift from simply writing code to stewarding the behavior of the systems that we create. So we need to be aware of that, acknowledge that, and own that. And it's our responsibility. So I think environmental impacts are gonna play a really big role in this, and they already have. By 2030, these AI data centers could account for 12% of all of the US electricity use, relying, obviously very heavily on fossil fuels. And for example, I heard a quote or a statistic that ChatGPT uses 17 ounces of water for every 5 prompts, which is interesting. So I think we really need to be aware of what we're doing here because small engineering decisions do add up. Most of AI's environmental impacts come from compute. They come from training and inference and infrastructure. So that's on us, right? So I'm not saying don't use AI, but use it intentionally and efficiently. And as I mentioned earlier, as a best practice anyways, use the smallest model that you can. I always want to throw these big models at everything, but hey, I think a smaller model might work just as well half the time. So be thinking about that. How can I replace these things? What are the small things that I can do? I also kept telling the agent a lot of times, or I say like, thank you back. And I'm like, wait, that was like such a waste. Like I don't need to do things like that. So just being really mindful of what we're doing and making sure that we're optimizing and only making a tool call when we need to. You can also reduce unnecessary model calls by caching. You can evaluate before you scale. And one of the biggest hidden costs is scaling something that's inefficient, right? Also, run evals. Evals, again, are super important to confirm model quality before they go to production and just check if you can use something smaller. Another big thing that's a hot topic right now is building the next generation of developers. I think that's also going to play a big role in this. A group of engineers at Microsoft recently published a paper. I'll post this because I think it's super interesting. Because once I read it, it was really, really stuck with me. But basically, it talks about how seniors are really going to get this crazy AI boost, right? We're going to be super effective. We're going to build things faster than we've ever built. Just yes, rocket ships. Here we go. 10x Ninja developer. Whereas junior developers with AI are just going to be dragged down by this. They're not going to understand. They're going to ask, a coding agent something, a CLI to do something for them. They're not going to understand it, be able to review it well. And if something breaks, they're not going to be able to fix it because they truly don't understand. So a huge AI drag. And we all know that AI is not a replacement. It's a multiplier for judgment. So the role of engineer is really shifting. We're going to be spending more time doing more senior principal staff type things, defining problems, guiding systems, verifying outputs, systems design, different things like that. So, obviously things that junior developers have never seen before and are not going to be very good at. But I think that it's our responsibility, to figure this out. AI changes how we build software. It's our responsibility to teach the next generation of engineers how to work with these tools. So not just how to prompt them, but how to work with them, how to build them, design them, and know when they're wrong, steer them, all the things. So the same group of Microsoft engineers that I mentioned who wrote this paper, they present this program that they want companies to establish. It's called a preceptor program, where they intentionally mentor junior developers on how to work with AI, how to use it, how to determine if this is good code, bad code, that sort of thing. So I thought that was really cool, having a mentorship program that specifically works with junior engineers on that, because yeah, we don't want that huge drag. This is also going to be a thing. There is this mindset, and a lot of big companies are adopting it, that AI can replace us all. But I really think it's our responsibility to move away from this mindset and embrace that AI enhances us and makes us faster. It does not replace us. We can simply just achieve more. That's it. Bottom line, we are not all replaceable. And I really hope that we can, influence our companies to have this mindset versus, like Block, let's just lay off half our staff because we don't need them anymore. Also, stories like this will be a thing, and I want to hear about how AI tools are doing more good for the world. So this is Dave. I know Dave, he works at Microsoft, so I've met him a couple times, and he's a really great guy, but he has cerebral palsy, and AI has completely changed his life. And this is a quote he told me, so I'll let you read it, I won't read it. But he uses a Copilot CLI with dictation and can write code even though he cannot type. Traditional voice tools are great, but they replaced the keyboard but kept the complexity. And voice-first AI really replaces the complexity itself. And it's not just an accessibility story for him, it's a universal productivity story. And he also told me that he's never felt more free in his life. He finally has freedom because he can do the things that he wants to do. And that just really inspired me. I'm like, oh, AI has such a negative spotlight right now. And hearing stories like this is really compelling and awesome. And I want to zoom on this part of the quote. No longer are we bounded by computer science backgrounds or the ability to type, not knowing the syntax. Everyone can be more productive and we can also have more time to do the things that we love. We can still build the same amount of software in the same time, but maybe have more free time to spend with our kids or do the things that we love. Sorry, I know not everyone has kids, but I really think that this is an exciting time that's being shadowed by the greed of big companies. And yeah, so it's sad to see because I think that this could be a really good thing. We have choices as engineers and leaders on the forefront of this, building these agents. Like, we are the first industry, I think, to really kind of show the world what's gonna happen. So we can hide the complexity of these tools, or we can teach the next generation of engineers how they actually work. And we can build systems that replace humans, or we can just build systems that enhance them. So I'm curious kind of what you're gonna do with it. That's my question to you. Kind of which way are you gonna choose? What are you gonna do with this power? Thank you, that's all I have today.